Hey everybody, your friendly math tutor here with the Daily SAT Challenge, Wednesday, August 19th, 2026. So here we have a word problem that they give us like a formula about the pressure being of this force is the product of, it's the force is the pressure times the area. And then they give us this pressure. But since that pressure is involved in like everything, we can kind of ignore it in a way. So what we need to focus on is that we have these two circular pistons. So let me try to draw them like something. Whoops, that was not too good, but let's pretend that's a circle. And what we have is that we have this radius here is, let's just, for example, let's say it's 1. So then the radius here would be 5. All right, so it just says the radius of the larger piston is 5 times. If we understand scale factors, what that would mean is the area of this circle would just be pi, and the area of this circle would be 25 pi. So the key is that the area of this circle is going to be 25 times the area of this circle. So then we could look at the area, like the total area of everything is kind of, we can look at it as the 1 plus 25 is 26. And the smaller one, it says the total force exerted, and it says what's exerted on the smaller one. The smaller one is going to be 1/26th of the total area of both. So again, if we made this 1, we would get an area of pi. If we made this 5, we would get an area of 25 pi. The total area would be 26 pi. And this pi out of 26 pi would be 1/26th. Or just scale factors in general. If the scale factor is 5, the area is going to be 25 times it. So all we have to do in this problem is take that 1/26th and multiply it by 7,800, because that's the total force exerted over the whole thing. So this small one should just take up 1/26th of that, and that turns out to be 300. Now you could do it and use the actual formula given, but both of them are going to include that 150. So like every time you use the formula, that's why we can kind of ignore it. If that was different for the small one versus the bigger one, then we would have more work to do. But in this case, it's just kind of understanding that the small one is going to take up 1/26th of the total. So then it should therefore take up 1/26th of the total force exerted. All right? Hope that helped.